Okay, so first thing we're going to need to do is we have to classify which is acid and which is a base. And the easiest thing to do is look to see if I have literally given you an acid. And that's what this one is. This is sulfuric acid. Acid is in its name. It is an acid. It's always going to act as an acid. And that means the other substance has to be acting as the base. Now we have to remember by definition what acids do. They give hydrogens over to the base. So we're going to move one single H plus over to water. So if H2SO4 loses one hydrogen, it is now HSO4. And if H2O gained a hydrogen, it is now H3O. Charges, that's the next thing to worry about. We're moving a single H plus. So if this molecule was neutral and it lost something that's positive, it is now -1. Because it was neutral, it lost a positive. This substance was neutral and it gained a positive. It is now +1. And let's not also forget that we need to put our aqueouses in here. AQ, AQ. Everything's going to be AQ on the right side here. Sorry, those do not look very good. We also need to label our pairs. So we need to come up with molecules that are different by a single hydrogen. So looking at water, water is different than H3O by a single H plus. So if water was acting as a base earlier, then this is going to act as a conjugate acid. The acid and base always pair up. And by default, and it does check out that this thing is different from this thing by a single H plus. So this must, and this was an acid, that must make this the conjugate base. Now B is exactly the same as A because the substance I give you is hydrobromic acid. Acid. That means the other substance has to be the base. And we start to ask ourselves, what do acids do? They give up hydrogens. So if HBr gives up its hydrogen, it's just now left with Br -1. And water is gaining one. It's now becoming that hydronium, that H3O plus molecule. So add in the AQs. Sorry, though, it's very difficult for me to draw those in. Oh, that's terrible. And we also have to do our pairs. Now let's see here. This one is an acid, and it's going to pair up with that one there. So that makes that a conjugate base. And by default, this has to be a conjugate acid. And as well, it is different by a single hydrogen than that one there. Now I'd like to point out something at this point, that both times we started with acids, right? And both times we made H3O plus, and both times they ended up being the conjugate acid. So H3O plus is probably going to be a conjugate acid when it's formed. Now, keeping in mind here that for E, I'm looking down, I'm starting with phosphoric acid. So that one's got to act as an acid, and that's got to act as a base. So that's going to direct where our hydrogens move. Okay, let's clear the palette here and look at C. This is an unusual one, but it does tell us that we're making something that's acidic. Now, the acidic molecule is H3O plus. You know it's acidic. You can automatically write this thing down and then sort of work backwards. How do we actually make H3O plus? Well, let's see. It's pretty close to H2O. And if we were to take a hydrogen from there to there, we would make H3O plus. And that's exactly what we're doing here. So now that we've decided that, then what this compound is doing is it's giving up a hydrogen. It's acting as the acid. It is giving it away. The water is acting as a base. So if this compound gives up one of its hydrogens, it's going to be one down one hydrogen. It was neutral. It gave away a positive. It's now -1. Notice our charges are always balancing here too. We had no charge on this side, and we have a +1 and a -1 that also equals no charge. In terms of our pair, let's see. We've mentioned this could be the conjugate acid. Well, let's check it out. It's pairing up with that. Water's a base. That does make this an acid. The words acid and base go together, and that has to be a base. So that is that one. Moving on to D. Now, this compound here doesn't have any hydrogens to give away. That means the only thing it can do is accept. So it has to be a base. Bases accept hydrogens. And water is going to now act as the acid because it can give them away. So it's going to put one of its hydrogens over here. One way you could think about this, there's probably multiple ways, is we're making CaOH. It was neutral. It gained a positive. It's now +1. And what other thing are we making? Well, H2O, I would think of it as being HOH, right? That's water, H2O. So what's happened is this hydrogen is getting kicked off. So what's left over is the OH. OH -1 aqueous. In terms of our pairs, let's see, these two are pairing up. This is an acid. This is going to be our conjugate base. Maybe that's not surprising because this is the basic molecule. It's a conjugate base. And this is a conjugate acid. I already mentioned E earlier. You should be able to figure that one out. The last one we'll look at is F here. This compound, again, doesn't have any hydrogens to give away, so it has to accept. It has to be acting as the base. Also mentioned earlier that things that are negative or positive want to get back to neutral, so they're either going to gain hydrogens or lose hydrogens, depends on the situation. This thing is going to gain some hydrogens to go from -2 back up to positive. The other compound here is hydrogen sulfide. It's got a couple of different names. It's an acid though, so that's going to act as your acid. So we're going to take one hydrogen, put it over here. So CO -2 now is HCO3. It was -2, it gained a positive, so now it's a -1. And we're down to HS. It was neutral, lost a positive. It now has a charge of -2. Don't forget your aqueous is here. I'd like to point something out also about the charges, is that, oh geez, if you look at the total charge over on this side, this molecule was -2 and this was 0. So kind of the net on this side was -2. Over here now we have -1 and -1. Well, heck, that adds up to -2. So our charge is maintained -2 on both sides. And lastly, in terms of our pairs, let's see. This one should be the conjugate acid, pairs up with that, and this should be the conjugate base. So hopefully that helped out with some of the homework questions.